Okay, here's my next lesson. So this is lesson 67 from page 468 in the textbook, and it's called Newton-Raphson method for root finding. Okay, so what we've got here, this is this method here, and this is what we're going to work with today. This is a way to estimate the roots of an equation. If alpha is a root, i.e. a value that makes f of x equals to 0, then the iterative sequence given by this, so it's xn plus 1 equals x to the xn minus f of xn divided by the derivative evaluated at xn, and that will converge to alpha if it converges. Okay, so the equation x cubed minus 2x minus 3 has exactly one real root alpha, where alpha lies between 1 and 2. Take x1 is 2 as the first approximation to alpha. Use the Newton-Raphson method to find the second and third, and give answers to 3D, P where appropriate. Okay, so for A, we've got xn plus 1, xn minus f of xn, f dashed of xn. So this is Newton-Raphson. So this is xn, and then f of xn is x cubed minus 2x minus 3, and the derivative of f of x is 3x squared minus 2. Okay, and these x's are xn's. Okay, so if you've got one solution, or one approximation, you substitute it into this right hand side, and I'll get you the next one. So x1 is 2, x2 is 2 minus 2 cubed minus 2 times 2 minus 3 divided by 3 times 2 squared, oh silly thing, 3 times 2 squared minus 2. So it's 2, and on the top there we've got 8 minus 4 minus 3, so that's 8 minus 7, which is 1, and on the bottom we've got 3 times 4, which is 12, minus 2, which is 10, so that's going to be 2.9, sorry, 1.9, and then the third approximation is 1.9 minus 1.9 cubed minus 2 times 1.9 minus 3 divided by 3 times 1.9 squared minus 2. And I've got the answer in front of me. It's 1.8933 dot dot dot, which is 1.893 to 3 dp. Okay. Use a change of sign, this is for part B, to show that the iterates converge to 1.893 to 3 dp. So what we can say there, 1.893, if we go either side of it, it's 1.8925 is one side of it, and 1.8935 is on the other side. So one of these should be positive and one of these should be negative. So if we say f of x is x cubed minus 2x minus 3, f of 1.8925, and that is negative, I've got the answer in front of me, 0.069. F of 1.8935 is positive, 0.0018. So there's a sign change. So we can say alpha lies between those two values that make the sign change, and all those numbers there, alpha is 1.893 to 3 dp. Okay. Right, example 2. Oh, there's an exercise there to look at. Example 2. So this says the diagram or the design, this shows for a sports field is a sector of a circle ABC with, let's just do this, that's a sector, oh, it's not going to work. A sector of a circle ABC, centre A, once we draw up a circle, radius R. Do it with a bit of a straight line. Centre A. So a sector of a circle is a bit like a slice of a pie. I would really like that to meet that one there. That'll do. Okay, centre A, and then that's B, and that's C. And the radius is R. The acute angle B to A to C is alpha radians. And the point D on AB is such that the line CD is perpendicular to AB. So that means C to D, D's on AB. That's not quite right. Let's go from there to there. So this is a right angle. And that's D. The length C to B must be 30% longer than C to D. Okay. Right, so we know that the length of C to D is, it's going to be R sine alpha, because C to D, here, this line here is opposite this angle. And so if we've got the opposite, and we've got, that's a right angle there, and the hypotenuse is R, so we've got an R in there, that's what we want. So opposite is hypotenuse times sine of the angle, which is sine alpha. Then we want the length of CB. And this is, if you remember the arc length, it's r theta. So this is r times alpha. Arc length is r times theta, where theta is in radians. Okay. Now CB is 30% bigger than CD. So therefore, r times alpha is 1.3 times r sine alpha. So where that's come from, 30%, 1.3 is a 30% multiplier. So 1.3 times this, which is the CD, that's going to make that 30% bigger, and that's what we want the r alpha to be. Anything else here? R alpha equals, yep, use the Newton, right, so that's all the setup there. Use the, oh, well, this one we can divide both sides by r. And then, because it's Newton-Raphson and we want it to be equals, set equals to 0, so we can say alpha minus 1.3 sine alpha is 0. And that's what we've got to use for the Newton-Raphson. So the Newton-Raphson, the blue on this side here, xn plus 1 is xn minus f of xn over f dashed of xn. So we can say xn plus 1, xn minus f of xn, all divided by f dashed of xn. Okay. And so what we can do, what we're going to start with, what do they use in the book? They start with, I don't know what they start with in the book. Let's start with 1 radian. Right, let's say x1 is 1. Okay, so x2 is 1 minus, this is xn, f of xn is alpha minus 1, 3. We've turned it into x's. Let's turn that into x's as well. xn minus 1.3 sine xn, all divided by derivative 1 minus, and sine differentiates to cosine 0.3 cos xn. So we've got 1 minus 1.3 sine 1 divided by 1 minus 1.3 cos of 1. Okay. And your calculator's got to be in radians. Calculator in radians mode. And I'm going to use, have I got the same as the book? Theta 1 is 1 radian. Yep. We call it x1 is 1 radian. x2 is 1.31 ... is what they've got there. And then if you do the same for x3, so you do 1 minus 1 minus 1.3 sine answer divided by 1 minus 1.3 cos answer. And then use your answer button on the calculator, and that will come up as, I'm taking this from the book, 1.22, etc., etc. And then the next one is exactly the same as what we've got there above, using the answer button, and that will come up as 1.22 as well. Okay, and then in the book they also go on to say f of f of n.15 is negative. So that's what you get when you substitute 1.15 into there. That one's negative. And if you do f of 1.25, that one was positive. So that means that theta is 1.2 radians to 1 dp. Okay, that's the end of that one.